Morning everyone. Today I'll be talking about the limbus, its structure and basically the surgical anatomy. Now what is the limbus? It is the circumcorneal transition zone of the, now see if this is the limbus, right? This is a cornea and this the periphery of the cornea we generally refer as the limbus. Around it is the conjunctiva. So this is the, and below the conjunctiva we have the tenons and the sclera. So this limbus, it is a transition zone of conjunctivo-corneal and the corneoscleral junction, right? And here this bulbar conjunctiva is firmly adherent to the underlying structures. Now this I made a rough diagram of the limbus, hope you are able to understand it. See, this is the cornea, this is the periphery of the cornea. So this what we call as the anterior limbal border. This is the mid limbal line, right? This is the mid limbal line and this is the posterior limbal border. Between the anterior limbal border and the mid limbal line we have a blue limbal zone, and between the mid limbal line and the posterior limbal border we have a white limbal zone. Now what actually is the anterior limbal border? It is a ridge which is created by the insertion of tenon and conjunctiva into the cornea, and it overlies the termination of the Bowman's membrane. Now this is important, this overlies the termination of the Bowman's membrane. Now this is a ridge which is created by the insertion of the tenons and the conjunctiva onto the cornea, which overlies the termination of the Bowman's membrane. Now then we have a mid limbal zone which is the junction of the blue and the white area, and here what is, here's the termination of the Descemet's membrane. Here what we have, that is the termination of the Descemet's membrane, that is the Schallway's line. And the Schallway's line is the structure from where the angle structure starts. Schallway's line, then trabecular meshwork, then scleral spur, right? Between these two, that is the anterior limbal border and the mid limbal line, we have the blue limbal zone, and its extent varies in different quadrants. Like the superiorly it is 1 mm, inferiorly like or the 6 o'clock it is 0.8 mm, and nasally and temporally it is 0.4 mm. Okay, now after this we have the the important thing about the mid limbal line is there is a junction of the blue and the white area. It is the termination of Descemet's membrane and the Schallway's line. It is the most useful external landmark. Why can we appreciate it? Because the color changes here, white to blue. It is preferred site for cataract incision, because you will because if the incision becomes deep, you will not be damaging anything, because there is nothing very much important below it. Okay. Now after this we have the white limbal zone. Now as we all know that as the Schallway's line ends, the trabecular meshwork start. So this white limbal zone, it overlies the trabecular meshwork. Okay, it is a constant zone in width, all in 4 mm everywhere. Now we have a posterior limbal border which overlies the scleral spur and can only be seen by sclerotic scatter method of illumination. Okay, now this is the surgical anatomy of the limbus. Now we'll be talking about what actually is the anatomy of the limbus. See, this I made a rough diagram, hope you will be able to appreciate it, although this video is a bit blurred. This is what is conjunctiva, this is limbus, and this is the cornea. These are the ocular surface epithelial cells which you all can see. Below this, these are the basal epithelial cells. These ridges or these depressions, these are the palisades of Vogt. These palisades of Vogt, these are very important structures because they contain the stem cells. And this, what is this? This is the Bowman's membrane layer, right? The Bowman's membrane layer is a layer in the cornea, as you all know. And below this Bowman's and below these palisades of Vogt, what we have? We have the lamina propria. Okay, this lamina propria, as we all know, is a layer in the conjunctiva. Okay. So what does the palisades of Vogt contains, or what it is actually? It has the pigmented basal epithelial cells which helps in protecting the stem cells from the UV light. See, it contains pigment, so it protects the stem cells from the UV light, and it also contains the stem cells which helps in filling up of an epithelial defect. Okay, bye bye.